Good evening everyone. Today we will practice some questions on Taylor series, Laurent series and calculus of residues. So first I have taken some of the questions from Taylor series. Here is the Taylor series formula, that is f of z equal to f of a plus f dash a z minus a plus f double dash a. Double dash means double derivative of f of a by 2 factorial z minus a whole square plus dot likewise it will continue up to f derivative to the power n by n factorial into z minus a to the power n. First question I have taken that f of z equal to 1 by z. Since since f of z equal to 1 by z and the question has asked that find the Taylor series about a equal to 2. So in place of z we will put 2, that is f of a equal to 1 by 2. Then we will find the first derivative of f of z. That will be by putting the derivative formula du by dv equal to minus n z to the power minus n minus 1. Here n is minus 1, so it will be minus 1 by z to the power minus 2. So in case of f of first derivative of 2, that will be minus 1 by z square. Then into z minus a. In place of a we will put 2. Likewise I have written that first 1 by 2, second derivative of f of a, that is minus 1 by z square, in place of z minus 1 by 2 square into z minus 2. Then third derivative of f of a means f of 2, that will be minus 1 by z square, again derivative, that will be z square, means z to the power minus 2, so minus 2 into z to the power minus 3, that will be minus 1 into minus 2, 2 by z to the power 3, or 2 into z to the power minus 3. Then in place of second derivative of f of 2, put 2 by z cube by n factorial, that is 2 factorial, since it is second derivative. So in denominator we will write n factorial into z minus 2 whole square plus dot dot dot. Likewise it will continue up to the nth derivative of f of 2 by n factorial into z minus a, that is z minus 2 to the power n. Observe the pattern that first we get 1 by z, second first derivative, that is minus 1 by z square, second derivative 2 by z cube. So what will be the nth derivative? Now minus 1 to the power n into n factorial divided by z to the power n plus 1. Here 2 by z cube it is, so in place of denominator we will write z to the power n plus 1. So in place f to the power nth derivative of f to the power 2, we will write minus 1 to the power n into n factorial by z to the power n plus 1, and by putting the formula z minus a, that is z minus 2 to the power n by n factorial. N factorial will cancel out, and we will get the required derivative of f of z. F of z about point 2. Then I have taken one question that f of z equal to log z. So f of z is log z. First, what will be the first derivative of f of z? That is d by dz of log z, that is 1 by z. And if first derivative of 2, we will find the question at point 1, a equal to 1. So if first derivative of 1 equal to 1 by z, that is 1 by 1, that is 1. Then likewise if second derivative minus 1 by z square, if third derivative 2 by z cube, and if second derivative about 1, then minus 1 divided by z, in place of z square 1 to the power whole square, that is minus 1. Then third derivative 2 by z cube means 1 to the power cube, that is 2. then fourth derivative and fifth derivative. Likewise we will continue. In Taylor series formula we will put f of 1 equal to 0, since log 1 equal to 0, as we all know, and f dash 1 is 1 and into z minus 1. F double dash 1 by 2 factorial, f double dash 1 is minus 1 by 2 factorial into z minus 1 whole square. F triple dash 1 is 2 by 3 factorial into z minus 1 whole cube. In this way that series will continue. Then take another question. 1 by z square minus 3z plus 2, and the question is given that z is less than 1. First question. Second question, z is greater than 2. If first we have to convert the denominator into the factors, that is z square minus 2z minus z minus 2. That means z square minus z common z minus 2 minus 1 z minus 2. So what are the factors? Z minus 1 and z minus 2. This is a partial fraction applied here, which I will provide you the trick that a by z minus 1 plus b by z minus 2. Solve this equation, then equate the a plus b value to 0. Here as in the numerator part there is no z, and the constant part to 1. Then find the a and b value, that will be 1 and b will be minus 1. So we get the fractions that 1 by z minus 2 minus 1 by z minus 1. Then we will apply the binomial equation here. Since it is given that z is less than 1, so z will be also less than 2. In z minus 2 case, we will take the bigger term common. Between z and 2, 2 is the bigger, then we will take minus 2 as common. In bracket it will be 1 minus z by 2. Then again in case it is z is less than 2, and we will take the 1, we will take 1 common, minus 1 common, that will be 1 minus z. If the denominator will come to the numerator, that will be minus half into 1 minus z by 2 to the power minus 1, and here 1 minus z, minus minus plus 1 minus z to the power minus 1. Then apply the binomial expansion here. 1 by z to the power minus n equal to 1 plus nz plus n whole into n plus 1 by 2 factorial into z square plus n whole into n plus 1 n plus 2 by 3 factorial into z cube. This is a binomial expansion of 1 minus z to the power minus n, and put here, and we will get the series. Then take the second question. Here it is z greater than 2. As I have told you that we will take the bigger term common, and here the bigger term is z. So we will take the z common. Then our equation will be 1 minus 2 by z, and here 1 minus 1 by z. If it comes to the top, then it will become minus 1, it will become minus 1. Then apply the binomial series here. 1 plus nz plus n into n plus 1 by z square plus n into n plus 1 n plus 2 by z cube. And here also 1 plus 1 by z plus 1 by z square plus 1 by z cube. Then solve the series. We will get the required series. I have taken one more question upon Taylor series. We will solve this question by two methods, binomial method and Taylor series expansion method. First take the binomial method, z plus 1 by z minus 3, z minus 4. We will find the expansion at about z equal to 2. Apply the partial fraction method here, that I have told you, that take a by z minus 3 plus b by z minus 4 and equate it to the series that is given, that z plus 1 by z minus 3, z minus 4. Denominator cancels out, and equate the equation, equate the coefficients of z to the coefficients of z, that is 1 here, that means a plus b equal to 1, and the coefficients of constants that will be equated to 1 here, that is minus 4a minus 3b equal to 1. Then solve these two equations. We will get the a value minus 4 and b value 5. We will get the required fraction, that is minus 4 by z minus 3 plus 5 by z minus 4. Since the question has given that find the expansion about z minus 2, so convert the numerator, that is z minus 2 minus 1, z minus 3, and z minus 4, z minus 2 minus 2. Then I have told you that take the bigger term as common. Since 3 and 4 are outside the equation, so z minus 2 will always be less than 1, 3 and 4.